Today, being able to recognize the 8 parent functions and be able to work with the domain and the range. And so if you don't remember the topic of domain and range, and that's again from Algebra 1, we'll come back to that. All right, so does everybody know where we're at in our notes? Yes, yes? Okay, so the domain of a function is basically the set of possible values that can happen in the independent variable. So that means you're really going to look at the x's. And so what can x be? What can x not be? And things like that. The range is looking at all the possible results that can come out. And usually that's going to depend on like what's going to happen with the domain. And so the domain kind of dictates the range because again, it's kind of a dependent relationship here. All right. And so I'm wondering if some of you guys can figure out what some of these, what they are by looking at kind of our equations here. So is there any of these that you guys think? So here are my choices. I have square root, cubic, linear, constant, quadratic, absolute value, rational, and cube root. I didn't list all of them, but I listed quite a few. So does anybody recognize any of these? Figure out which one's which. Okay, Avery, which one did you find? No? You just went like that? Okay. What about this one? Anybody know what this is? Cubic. Okay, so the first one is a cubic. Okay, anybody know this one? Absolute value. Okay, what about the next one? So what's this one? It's on the board. That's quadratic. Okay, this one I'm going to skip for a minute. This one we should know. Square root. Okay. Anybody think they recognize this one? Linear. This is linear. Okay, anybody think they recognize this? Cube root. Okay, and so we've used every word on the list so far. I mean, I used square root, used cubic, linear, quadratic, absolute value, cube root. So now we got 2 left. So which one do you think this one would be? That's constant, yeah. So that's where we put like our fabulous horizontal lines. They're constants. And then this one, of course, is called rational. Okay, so technically you have more than what I originally had on the board for parent functions, but we're not going to spend a super amount of time on graphing all of these. So we'll mostly focus in this chapter graphing again, absolute value, quadratic, a little bit of square root, and a little bit of cubic, but some of these other ones might not be as horrible with that, but we might still take a look at them. All right, so we're going to name what the function is, we're going to write the equation, and then we're going to talk about what the domain and the range is. And so we're going to take a look at each parent function and do that. And so that's all we're going to do. So we're going to look at all the separate ones and then see if we can figure out the domain and range and do that. Okay? So anyways, all right, so let's go back to this one. So this one we knew it was linear, right? The equation was f of x is equal to x. Okay, so is there any value that I can put in it for x that's going to make this not work? It's not going to work at all. No, anything works. So anything works. It's good to go. So therefore the domain would be x is all reals. Anybody know the abbreviation for reals? You can do that funky looking R. So that's all reals. Now, if the domain is all reals, that's going to kind of dictate your range. And so your range is also going to be all reals. So when we graph things, that's why it's important to kind of know the domain and the range so then we know what it's kind of looking like and so forth. Okay, next one, that is our quadratic. Okay, equation would have been f of x is equal to x squared. Any value that I can't plug in for x. I'm going to not get an answer coming out. Are we good? All reals. And again, since the domain, there isn't anything going against the x's that are bad, then the range would be all reals as well. But wait a minute. I don't know if that will necessarily work. Look at my picture. What kind of y coordinates don't I get? Oh. So sometimes even if the domain is all reals, sometimes the range will be a little bit different because we have this counteracting on it, and again, anything negative will become positive. So therefore, my range is basically going to be, my y values are going to be greater than or equal to 0 because I don't have anything going down in the third or fourth quadrant. So that's going to be my range. The next one, that's your cubic. Equation would be f of x is equal to x cubed. Domain, there isn't any number that's bad in a cubic. It's all reals. And the range is also going to be all reals because you have negative numbers and positive numbers, so you are okay. So far that's, again, our 3 parent functions. Again, we got to learn the parent functions before we can learn about how to do the transformations. So that's a little bit of the difference with that. Okay, the next one. Anybody think they know what the graph of that is? Nothing? That's a cube root. So that's a cube root. Again, we have f of x is equal to the cubic root of x. Okay, is there any x that I can put in that's going to mess up a cube root? No. So domain's going to be all reals. And you can get negatives coming out, so the range is all reals. You'll get positive numbers and negative numbers, so that will be fine. Anybody know the next one? The next one's kind of weird looking. Looks like he's missing something, but not really. It's not rational. Good thinking, though. This is square root. Now, square roots are kind of funky. That's f of x is equal to the square root of x. Now, the domain, there is a domain. What kind of numbers do you remember that you cannot plug in for x in an or in a square root? Do you remember? Yeah, negatives, no negatives. So therefore, my domain would be x is going to have to be greater than or equal to 0. I can't put in negatives. Okay, that's impossible. I'm not going to get a value. Okay, and that's going to kind of dictate my range. So if I can't put in a negative number, then therefore I'm not going to get a negative number coming out. So that's going to force my range to match my domain. So that's what we're going to have for that part. The next one, that is going to be my constant. So this is an example of what a constant equation would look like. And again, this is going to be just f of x is equal a number. We just represent that with c. So c just represents a number. We can pick anything for the domain. So that's all reals. But the range is going to be kind of weird. If you think about it, if I put in any number I want in for x, how does my y change? It doesn't. So therefore, my range would just be whatever the constant is. So that's kind of weird. But that's the output that it's going to produce. Okay, finally we got our last two. This is rational, by the way. So some of you guys that were thinking the other one was rational, this is rational. We'll spend more time this year talking about rational. Rational is kind of a weird looking one. And so that's the equation of f of x is equal to 1 over x. Is there any x value that I could plug in that would make this poopy? There is a value, but I want you to find it. 0. So this one, everything will work except for 0. That's why it makes these weird curves. Because notice as it's approximating and getting close to that line of x equals 0, it's going wonky. So therefore we have that happen. But for the range, I mean, the range for the most part is going to be okay. It's just that if x is not going to equal 0, you're never going to have y is not going to equal 0 either. Because I can't get a number divided by another number and get it to equal 0. That's just impossible. It's not going to do it. And then the last one, of course, you guys should know because that's absolute value. Equation is f of x is equal to the absolute value of x. Can I put in any number I want for x? Yep, all reals. And then notice, wait a minute, there's nothing down here, so what is that telling me about my y's? Yep, they're greater than or equal to 0. So there's all your parent functions in a nutshell. What do you think? Yay? Nay? All right, so let's take a look at the picture, see if we can figure out what family is it from, what is the domain, what is the range, because that's what you're going to have to do on your homework. Make sense? So with number 1, what do you think it is? So first figure out what family is he. Linear, good. Okay, then you kind of look at your sheet and you look at your notes. What's the domain? All reals. And then what's your range? Should be all reals. For a linear, absolutely. Because you're going to have positive numbers, you're going to have negative numbers, you're going to have 0. You're good to go. Okay, what about this one? This next one, what family does he come from? Yeah, this is quadratic. So you should always be able to identify the family. Now, this one where we have to kind of take a look at it. Now, can I pick any number I want for x? Yes, I'm okay. So all reals. Okay. Notice though it shifted the graph down just a teeny weeny bit. So that tells me I don't have any values though that are lower than that. So I know y is going to have to be greater than or equal to wherever the vertex is at. So anybody think they can figure out what number that is? -2. So that would be my range. So y is going to be greater than or equal to -2. Okay. What do you think number 3 is? What family? That's a rational. So that's rational. Okay. And then it's got to have that domain. So now we got to figure out where is it going wonky. So what I kind of do is this. I kind of draw this in. And that kind of helps me find what's the wonky value. So x cannot equal -3. Because otherwise it's going to go wacky taffy. And then for the range is going to be fine. It's just that for this, we'd have to take a look at it. What would we have for the range? The range would be, when will I have a value not equal it? I would have that. I won't have, y can hit here, y with that. Y won't hit 0. It will approximate it, but it won't get to it. So that would stay consistent. What do you think 4 is? Yeah, that's another rational. Rational are the ones that sometimes give people Heber fits. Okay, domain, there's got to be one bad value, so then you have to kind of throw it down and figure out where the heck is the bad value. Some of you guys are saying 4. I heard that. That's right. So x can't equal 4. And again, the range kind of stays consistent as well. So you're not going to have, however, this one's going to be different because it's not approaching that, it's approaching this line. So therefore, y cannot equal 3. So this might be an area where we might have to have a little bit more conversation with. And then we have the last 2. So what do you think number 5 is? It could be exponential decay. That's true. And it is exponential decay. So that's true. So that's not a family member. It's just exponential decay. Does anybody think they know what values would not work for a domain? So is there any numbers that go bad in an exponential? No, all reals. Okay, now we got to figure out the range. Notice it's kind of getting smaller and smaller and smaller and smaller. So it went up really high. Will it continue to go down really, really low? I think it's going to go, but it's going to basically go and it's going to eventually peel off right around here. So therefore, we're going to have y is going to be, what do I want to say this as? Greater than or equal to -2 for that, because it's not going to dip down any further than -2, because it's going to match that limit. And then finally 6, that's not exponential decay. What is that? That's the square root. And then is there a domain? Yeah. Well, this one you got to be careful. A normal one would just be that x has to be greater than or equal to 0. But here we must have some kind of weird function in there that allows it to do that. So x is actually going to be greater than or equal to whatever this number is. So that would be -4. So there must be, like, in the bracket, must be something in there. So it probably is like x plus 4 underneath the radicand. And then the range, you're not going to have any negative numbers, so therefore y is going to be greater than or equal to 0, because that will stay consistent from the parent root. So you're going to get a worksheet. What you're going to do is figure out what family it is, and then figure out what the domain and range are. Make sense?